2026 A-Level Combined Mathematics Paper 1 Part B, question number 16, Part B. Part A of the same question was discussed in a previous video. Link in the top right. Part B, this question has to do with lines and circles in the Cartesian coordinate plane. The question says, let the circle S1 be given by x squared plus y squared minus 6x minus 4 plus 4 equals 0, and the circle S2 be given by x squared plus y squared plus 4y minus 5 equals 0. Now given this, they first ask us, show that the circles S1 equals 0 and S2 equals 0 have equal radii and that they intersect each other. They then say, also find the equations of the common tangents to these circles. Furthermore, let u be given by 2x minus 4y plus 3, and given that, find the equation of the circle that passes through the points of intersection of the circles S1 plus u equals 0 and S2 equals 0, and furthermore, also intersects the circle S2 equals 0 orthogonally. Now to start with this question, we need to know that if you have a circle S of the form x squared plus y squared plus 2gx plus 2fy plus c equals 0, then the center C of this circle is going to be given by the coordinates of negative g, negative f, and the radius r of this circle is going to be equal to the square root of g squared plus f squared minus c. Now looking at these two circles, we can see if we consider circle S1 and circle S2 and try to get them into this form, we'll have constants for g, f and c for both of these circles. Let's call them g1, f1, c1 and g2, f2 and c2. Now according to that, for the circle S1, if we take a look at the g term, 2gx must be equal to minus 6x, and therefore 2g is equal to minus 6, and therefore g must be equal to minus 3. So therefore g1 here will be equal to minus 3. Now similarly, if we do f1, 2f1 must be equal to minus 4, and therefore f1 must be equal to minus 4 divided by 2 or minus 2. So f1 equals minus 2. Now for c1, if you take a look at the constant term, we can see the constant term here is directly equal to plus 4, and therefore c1 must be equal to 4. Now similarly, if we consider circle S2 and first look at the x terms, over here we have 2gx, but over here we can see we actually don't have an x term. Now if you don't have an x term, the x term here is plus 0x. So therefore 2gx is 0x, and therefore we can say 2g is 0 and g is 0. So therefore g2 here must be equal to 0. Now similarly, if we consider f2, 2f2 must be equal to plus 4y, and therefore we can say 2f is equal to 4, so f is equal to 2. So f2 is equal to plus 2. Now finally for c2, the constant here is minus 5, and therefore c2 must be equal to minus 5. So going down, we have everything that we need over here to find both the center of these circles and also the radii of the circles. Now here, I'm going to find the radii first. So first we apply the radii formula. We can see for r1, we have r1 equals square root of g1 squared plus f1 squared minus c1, which is equal to the square root of g1 or minus 3 squared plus f1 or minus 2 squared minus c1, which is minus 4. Now simplifying, we can see that gives us 3 squared, which is 9, plus 2 squared, which is 4, minus 4. These two cancel and we're left with plus 9. So therefore we get the square root of 9, which is equal to 3. So therefore the radius of the first circle, r1, is equal to 3. Now considering r2, r2 is equal to the square root of g2 squared plus f2 squared minus c2. And therefore we get, if we substitute, 0 squared plus 2 squared and then minus c2, which is itself minus 5. So we get minus 5. Now simplifying down, we can see we get 0 plus 4, and then a minus 5 turns into plus 5, so plus 5, which is equal to the square root of 0 plus 4 plus 5, or 9. So it's also equal to the square root of 9, which is equal to 3. So therefore r1 and r2 are both equal to the same value, and therefore the radii of the two circles are equal. So we can say, therefore S1 equals 0 and S2 equals 0 have equal radii of r1 equals r2 equals 3. Now after the question then says, show that the two circles intersect each other. Now if two circles intersect each other like this, then we have some conditions that we can apply. So first off, if the circles intersect externally like this, then the distance between the two centers here is equal to the sum of the two radii. If instead they intersect internally like this, such that one circle touches the other circle inside, we can see the distance between the two centers is equal to the difference of the two radii. Now finally, if instead of that we have something like this where we are in between external touching and internal touching like this, then the distance between the two circle centers will be somewhere in between the sum of the two radii and the difference of the two radii. Now according to that, we need to find r1 plus r2 and r1 minus r2 modulus, which is the difference of the two, and then see if the distance between our two centers of these two circles is equal to this one, or somewhere in between these two, because in all three cases the two circles will intersect each other. Now r1 plus r2 is simply 3 plus 3, which is equal to 6, and r1 minus r2 modulus is simply equal to modulus of 3 minus 3, which is equal to modulus of 0, which is equal to 0. So therefore, if we have C1, C2 being somewhere in between R1 plus R2 and R1 minus R2 modulus, then the two circles will intersect each other. Now considering the centers C1 and C2, C1 is going to be given by the coordinates of negative G1, negative F1, which is going to be given by negative, -3, negative 2. So therefore we have negative 3, which is positive 3, so positive 3 here, negative 2, which is equal to positive 2. Therefore the center C1 of the circle S1 equals 0 is given by the coordinates of 3, 3. Now similarly, if you consider C2, center C2 is going to be given by negative G2, negative F2, and here G2 is equal to 0, so we have negative 0, which is 0, negative F2, and here F2 is equal to 2, so we get minus 2. So therefore C2 is given by minus 2. Now according to that, if we consider distance C1, C2 between the two center points of C1 and C2, it should be equal to the square root of the x difference squared plus the y difference squared. Now in terms of x difference, we have 3 here and 0 here, so the x difference is 3 minus 0 squared. Now for the y difference, we have 2 here and minus 2 here, so the y difference is going to be minus 2 minus positive 2, or we could alternate it right as plus 2 minus negative 2. So we have those two squared added together, square rooted. Now simplifying, we can see in the first bracket we get 3, and 3 squared is equal to 9. In the second bracket we get 2 minus negative 2, which is plus 4, whole thing squared, which is going to be 16. So we get square root of 9 plus 16, which is the square root of 25, which is equal to 5. So therefore C1, C2 is equal to 5. Now 5 is in between 6 and 0, and therefore our circles are somewhere in between intersecting externally and intersecting internally, which means they intersect like this. So therefore we can say, and we can say something like, since R1 plus R2 is bigger than C1, C2, which is bigger than modulus of R1 minus R2, i.e. the distance between the two circle centers is in between the condition for them to intersect externally and intersect internally, we can say the two circles must intersect at two distinct points. So with this we can conclude, therefore S1 equals 0 and S2 equals 0 intersect at two distinct points. And with that, we are done with the very first part of the question. Now moving on to the next part. The next part says, also find the equations of the common tangents to these circles. Now there are multiple situations we can have. If two circles are external to each other and never touching like this, then there are actually 4 common tangents that we can draw. They are this tangent going above like this tangent going below like this, which are both called direct tangents, and 2 other tangents, which are the tangents that cross in between the path in between the 2 circles, which are this tangent right here and this tangent right here, and these 2 tangents are called transverse tangents. So if we call this T1 and this T2, then T1, T2 are what we call direct tangents And the other two tangents here, which are called T3 and T4, are what we call transverse tangents. T3, T4 are transverse tangents. Now, in the case of two circles being external to each other like this, all four of these tangents exist. However, if two circles touch each other externally, like so, there will be, instead of 4, just 3. This one, and a very special tangent that crosses right in between the intersection of these two circles. So in the case of two circles touching externally, there are 3 common tangents. Now instead, if two circles intersect at 2 points, like what we have with S1 and S2, then there will only be 2 common tangents, as this tangent right here and this tangent right here. Furthermore, if two circles intersect internally like this, then there will be only one common tangent, which is this common tangent right here. Now finally, if the first circle or the smaller circle is inside the larger circle, then there will actually be 0 common tangents. Now out of all of these scenarios, we are in the second to last scenario where we had two circles intersecting at 2 points, and therefore these two circles should have 2 common tangents. So as you can see, I've drawn a diagram of the circle S1 equals 0, S2 equals 0, the centers C1, C2, the line between them, and also the two lines T1 and T2, which are the 2 common tangents to the circles S1 and S2. Now looking at the diagram, you can see something interesting in that since the circle S1 equals 0 and S2 equals 0 have equal radii, not only are these two tangents T1 and T2 parallel to each other, but they are also parallel to the line C1, C2 in between these two centers. Now according to this, the gradient of T1, gradient of T2 and the gradient of C1, C2 must all be equal to each other, and we can use that to find the gradients of T1 and T2. So if we consider gradient of C1, C2, we can see gradient of C1, C2 is equal to y2 minus y1 divided by x2 minus x1, which will be equal to 2 minus negative 2 divided by 3 minus 0. So 2 minus negative 2 divided by 3 minus 0, which is equal to 4 over 3. So therefore the gradient of C1, C2 is equal to 4 over 3. Now in this case, if all 3 lines here are parallel to each other, then we can say gradient of T1 and T2 must also be equal to 4 over 3. So we can say since T1 parallel to T2, which is also parallel to C1, C2, gradient of T1 must be equal to gradient of T2, which is also equal to 4 over 3. So with that, we know the gradients of T1 and T2. Now if the gradient of these two lines is 4 over 3, then we can say, based on the form y equals mx plus c, the lines T1 and T2 must be given by y equals m of 4 over 3 times x plus a constant c. Now in this case, since I've used c more than once here, I'm going to instead use k as the constant. So we can write y equals 4 over 3 times x plus k. And we can say where k is an element of the real numbers. Now in this case, T1 will have one value of k and T2 will have a different value of k. And both of these values of k can be found by using the other common equations that we can get for the lines T1 and T2. Now other than this, if we take a look at the diagram, we can see not only are these two lines parallel to this line C1, C2, but both of them also have perpendicular distance of 3 from the centers of 0, negative 2 and also the center 3, 2. So this perpendicular distance is equal to 3 on both of these, and this perpendicular distance is also equal to 3. Now as we know, if you have a line of the form ax plus by plus c equals 0 and you have a point, let's say h, k like this, the perpendicular distance here, which we'll call d, is equal to the modulus of ah plus bk plus c divided by the square root of a squared plus b squared. Now according to that, if we get these two lines of t1, t2 into this form, we can then apply this equation and probably we will get the values of k. So therefore, if we try and first convert this line into that form, we can see we can do that by simply multiplying everything by 3 and taking everything to one side. So multiplying by 3, we can see we get 3y, 4x here, and 3k. And taking the y to this side, we can see we have t1, t2 being given by 4x and minus 3y, so minus 3y, and then plus 3 times k. So minus 3y plus 3k equals 0. So therefore t1 and t2 in this form are given by 4x minus 3y plus 3k equals 0. Now according to that, because for both of these lines the perpendicular distance from the point, let's say 0, negative 2 is 3, we can say since for both t1, t2, t2 perpendicular distance to the point 0, 2, we can say 0, negative 2 rather, 0, negative 2 to the point, perpendicular distance to the point 0, negative 2 is 3 units. Then the perpendicular distance d must be equal to 3, which is equal to the modulus of ax plus by plus c, which in this case is equal to 4 times the x value of 0. So 4 times 0 plus by, which is minus 3 times minus 2. So minus 3, or rather I'll cut the plus and just write minus 3 times minus 2 plus c, which is plus 3k, divide by the square root of a squared plus b squared, which is equal to 4 squared plus negative 3 squared. So 4 squared plus negative 3 squared. Now simplifying, we can see if we take to this side, we have 3 times the square root of 16 plus 9, which is 25, which is going to be equal to 5, equals the modulus of 0 plus 6 plus 3k. So 0 plus 6 plus 3k's modulus is equal to 3 times 5, or 15. So we get 15 equals modulus of 6 plus 3k. Now from that we can see we'll get either 6 plus 3k being equal to 15, or 6 plus 3k being equal to the negative value of the thing outside, which is negative 15. Because in that case also, if we substitute negative 15 inside the modulus of negative 15 is also equal to 15. Now solving these two, we can see for the first one, we get 3k equals 15 minus 6, or 9, which gives us k equals 3. From the second one, we get 3k equals minus 15 minus 6, or minus 21, which gives us k equals minus 7. So therefore, k is equal to 3 or k is equal to minus 7. And these two are going to be correspondent with the two lines t1 and t2. Now in this case, since t1 is higher up than t2, I'll say k1, which is a positive value, is going to be higher corresponding to k equals 3, and the other value k2 corresponding to line t2 is going to be negative 7. So therefore we can say let k equals 3 correspond to t1 and k equals negative 7 correspond to t2. Now according to that, we can see if we substitute into this equation, t1 will be given by y equals 403x plus 3. So we'll write t1 given by y equals 403x plus 3, and t2 will be given by y equals 403x plus k, which is minus 7, so minus 7. So with that, we have found t1 and t2, which are the two tangents that are common to both circles S1 and S2. Now finally, if we consider the last part of the question, it says, further, let u be given by 2x minus 4y plus 3, and given that find the equation of the circle that passes through the points of intersection of the two circles s1 plus u equals 0, which I'm going to call s dash equals 0, and s2 equals 0, and also intersects the circle s2 equals 0 orthogonally. Now for this one, we need to know that if you have two circles, let's say s1 equals 0 and s2 equals 0, that intersect at 2 points like this, and you have a third circle s3 that passes through these two intersection points, then s3 will be given by s1 plus lambda times s2 equals 0, where lambda will be some element of the real numbers. Now according to that, if we go up and consider what we're given, we can see for this particular situation, since our third circle here, which I'm going to call s3, passes through the intersection of these two circles, then we can say s3 must be given by this circle, which is I'm going to call s dash, plus lambda times this circle, or lambda times s2 equals 0, where lambda is some element of the real numbers. Now according to that, going down, what I'm going to do first is to find s dash, and then I'm going to substitute in that equation and get my answer. So going down, first we can say let s dash be given by s1 plus u. Now from that we can see this is going to be equal to s1, which is x squared plus y squared minus 6x minus 4y plus 4. So x squared plus y squared minus 6x minus 4y plus 4 plus the line u, which is equal to 2x minus 4y plus 3. So plus 2x minus 4y plus 3, which is going to be equal to x squared plus y squared, and then considering x terms, we have minus 6x and plus 2x for a total of minus 4x, and then minus 4y and minus 4y for a more total of minus 8y, and 3 and 4 for a total of 7, so plus 7. So therefore s dash is given by x squared plus y squared minus 4x minus 8y plus 7. Now considering that if s3 is the circle that passes through the intersection through the intersections of s dash equals 0 and s2 equals 0, then we can say s3 must be given by s dash plus lambda s2 equals 0, where lambda is some element of the real numbers. Now considering that, we can see if we go down and substitute in, we'll get s3 being given by s dash, which is this equation right here, of x squared plus y squared minus 4x minus 8y plus 7 plus lambda times s2, which is equal to plus lambda times s2 circle, which is x squared plus y squared plus 4y minus 5 equals 0. So we can substitute in x squared plus y squared plus 4y minus 5, and all of this added together must be equal to 0. Now simplifying, you can see we get x squared and another lambda x squared over 1 plus lambda x squared, and then y squared and lambda y squared over 1 plus lambda y squared, and then minus 4x and a plus lambda times 0x, so just minus 4x, and then minus 8y and lambda times 4y, or we can say minus 8y, or rather minus 8 plus 4 lambda times y, and then finally we get 7 plus lambda times minus 5, or a constant term of 7 minus 5 lambda equals 0. So therefore s3 is given by this equation right here. Now for this equation, if we divide by everything by 1 plus lambda in order to get the standard from a circle, we can see we'll get s3 given by x squared plus y squared minus 4 divided by 1 plus lambda times x, and plus minus 8, actually I can just write it as a numerator of minus 8 plus 4 lambda divided by 1 plus lambda times y, and plus 7 minus 5 lambda divided by 1 plus lambda equals 0, and this has to be true for lambda not equal to negative 1. Now considering that, we can see when we get this equation, if this thing right here is going to be orthogonal to the other circle, which is S2 equals 0, then we know if we have two circles of the form S1 given by x squared plus y squared plus 2 g1x plus 2 f1y plus c1 equals 0, and another circle in the form S2 given by x squared plus y squared plus 2g2x plus 2f2y plus c2 equals 0, then if these two circles are orthogonally intersecting, then we must have 2 g1 g2 plus 2 f1 f2 being equal to c1 plus c2. Now according to that, for these two circles, if we have the circle S3 and the other circle of S2 equals 0, which is this circle right here, this circle S2 given by this equals 0 intersecting orthogonally, then we must have the condition of 2 times g1 times g2 plus 2 times f1 times f2 being equal to c1 plus c2. So substituting in, we can see for the first circle we have g being equal to 0. So we have 2 times 0 times the second circle's g, which is minus 4 divided by 1 plus lambda divided by 2, which is equal, actually I'll just write that as just, I can easily divide it now. We write it as minus 2 divided by 1 plus lambda. Since this is equal to 2g, 1g will be equal to this divided by 2. So we get that. And then you have plus 2 times f1 times f2. Now f1 here is equal to half of this coefficient here, which is equal to 2. So f1 is equal to 2 times f2, which is minus this thing divided by 2, which is going to be equal to minus 4 plus 2 lambda divided by 1 plus lambda. And then we have this thing on the other side, which is going to be equal to c1 plus c2, or minus 5 plus 7 minus 5 lambda divided by 1 plus lambda. So we must have this condition right here. Now simplifying, if we cancel out this term right here, we can see both of these terms have denominators of 1 plus lambda in them. And therefore, if we multiply everything by 1 plus lambda, we'll get on this side 2 times 2, which is 4, times minus 4 plus 2 lambda. And on this side, we'll get minus 5 times 1 plus lambda and plus 7 minus 5 lambda. Now simplifying, we can see on this side we have minus 16 and plus 8 lambda, but on this side we have minus 5 times 1, which is minus 5, and then minus 5 times lambda, which is minus 5 lambda, and then plus 7, so plus 7, and another minus 5 lambda. So we get this equation right here. Now simplifying, we can see if we take this minus 5 lambda and this minus 5 lambda to the other side, we'll have plus 10 lambda. Taking that to this side, we have 18 lambda being equal to, and on this side, if we take the 16 this side, we have plus 16, and then minus 5 plus 7, which is going to be equal to 7 plus minus 5, which is going to be equal to 2, plus 16, which is 18. So we get on this side a total of 18. So we get 18 lambda equals 18. Now dividing both sides by 18, we can see we get lambda equals 1, and therefore the answer here for the circle S3 that intersects this other circle S2 at intersects the circle S2 orthogonally is going to be given by lambda equals 1. So therefore, going up, if we take this equation right here and substitute in lambda equals 1, we can see we'll get S3 being given by 1 plus 1, which is 2 times x squared, or 2x squared, plus 1 plus 1, or 2y squared, so plus 2y squared, and then minus 4x, which is going to actually, that one remains as it is, minus 4x, and then minus 8 plus 4 lambda, which is minus 8 plus 4, which is minus 4, which is going to be minus 4y, and then 7 minus 5 lambda, which is 7 minus 5, which is equal to plus 2 equals 0. We get that plus 2 equals 0. So therefore, finally we can say the circle S2 or S3 is given by 2x squared plus 2y squared minus 4x minus 4y plus 2 equals 0. Now finally, dividing everything by 2, we can see in standard form, S3 is given by x squared plus y squared minus 2x minus 2y plus 1 equals 0. And with that, we are done with the last part of the question. Now finally, let's go up and from the top discuss the marks awarded for this question. Now in the first part of the question, when you take these two circles in standard form, take their coefficients out like this and substitute them in like this. For doing all of that, you get 5 marks. After that, when you find R1 and R2, find that they are both equal to 3 units and hence both circles have equal radii. For saying all of that, you get another 5 marks. Now after that, when you consider centers C1 and C2, find the distance between them C1 C2 and find that it's equal to 5 units. For finding all of this, you get another 5 marks. And finally, when you then compare C1 C2 with R1 plus R2 which is equal to 6 units and R1 minus R2 modulus which is equal to 0 units, and then say, since C1 C2 which is 5 is in between these two, we must have the two circles S1 and S2 intersecting at two distinct points. For saying all of this, you get another 5 marks. Now after that, when you consider the two tangents here and realize that these two tangents are parallel to C1 C2 and therefore when you find the gradient of C1 C2 is equal to 4 or 3, you get 5 marks. And after that, when you then say these two are parallel to C1 C2 and then they have the same gradient, and from that, when you get that T1 and T2 are both of the form y equals 4 over 3x plus k, or the form T1 and T2 are both given by 4x minus 3y plus 3k equals 0, for either of these forms, you get 5 marks. Now after that, when you then use the fact that both T1 and T2 have a perpendicular distance of 3 from either of the points C1 or C2, and then substitute into this equation right here, for substituting this equation correctly, you get 5 marks for that. After that, when you simplify down and eventually get k equals 3 and k equals negative 7, for getting these two values, you get another 5 marks. And finally, when you substitute these two into T1 and T2 like so, to get these two equations, you get another 5 marks. Now after that, in the last part of the question, when you consider the circle S3, which intersects this circle and this circle S2, and then when you get S dash, which is S1 plus U, either over here or over here as x squared plus y squared minus 4x minus 8y plus 7, for getting it correctly, you'll get 5 marks. After that, when you get S3 equals S dash plus lambda S2 equals 0, where lambda is a real number, and you substitute them into this equation right here, for getting this equation, you'll get a total of 10 marks. Now after that, when you simplify down and get S3 in the standard form, which is this form right here, for getting this form you get 5 marks. And from that, when you then apply the condition of orthogonality, for the left hand side being correct, as in 2g1 g2 and 2f1 f2, you get 5 marks. And for c1 c2, c1 plus c2, you will get another 5 marks. Now after that, when you simplify down and eventually get lambda equals 1, for getting lambda equals 1 you get 5 marks, and when you substitute that back into this equation right here or this equation right here, and then you get S3 being given by x squared plus y squared minus 2x minus 2y plus 1 equals 0, you will get a final 5 marks. And with that, we are done with this question. So I hope you enjoyed. If you have any feedback or questions, post them in the comments down below. Thank you for watching and goodbye.